8. Are you getting there? Let me got my homework over here. Determine the value of the expression. In this case, we're working with, sorry about this. This would be a great time to fast forward. There we go. Fractions and decimals, you need to choose which you'd like. I mean, we could change this 75 hundredths to 75 over 100, or we could change it to 3/4, but then we'd have to have a common denominator. I think it might be better to just change the fraction to a decimal. So 3/5, remember 3/5 is a decimal-friendly fraction, right? I could multiply it by 2 and I would get 6/10. It's equal to 6/10. So I'd write that as 15 and 6/10 minus 19 and 75 hundredths. Now I'm going to fill in this here, so we'll have a common denominator. It's hundredths minus hundredths. And I see clearly that this answer is going to be a negative number. Maybe it's not as clear to use. Let me change it. I'm going to change it to addition of a negative number. And now I can see here I've got a positive number and I've got a negative number. And the negative number has a greater absolute value. So my answer is going to be greater. Now I need to find out how much greater. So 19.75 minus 15 and 6/10 is going to be 4 and 15/10. Wait. 5, 6, 7, 8, 9. Yeah, 4. Sorry. 4 and 75. No, that's a 15. I can't read my own writing. And 15 hundredths. Okay, it's negative 4 and 15 hundredths. The answer is C. Okay. This one is pretty straightforward. I'm going to let you, we can work this out in class if you need to. Let's move on to number 10. This one is worth going over. This is a big deal in 6th grade, in the 6th grade MSP and so on. And that is being able to order numbers from least to greatest, whether they're whole numbers or decimals or fractions or whatever. And the secret is, like with the previous one, is we need to pick a style of number. Do you want it to be a fraction or a decimal? And decimals are almost always easier to work with. So I'm just going to label these as the numbers 1, 2, 3, 4, 5, 6, 7. And down here I'm going to do the same thing. 1, 2, 3, 4, 5, 6, and 7. I'm going to rewrite them all as decimals. So that's 1.25, obviously. 9/5. I'm going to take a little bit of work here. That would be 1 and 4/5, right? 1 and 4/5. And that equals 1 and 8/10. Now I can write it as a decimal, right? That's 1.8. Sorry for using the P word. I mean 1 and 8/10. 3 is 0. That's already a decimal number. 2/3, we know, this is number 4. We know that that's going to be negative 2.66. There's that P word again. And number 5, 2 and 5/6. That's a little trickier. So let's hold off on that one for a second. 1 and 3/7, also tricky. I'm going to put number 7 here as 2, negative 2 and 5/10. These last two, let's take a look at number 5. 5/6. I'm going to need to use the cowgirl and the horse here to find out that decimal value. So I'll put the cowgirl in the house, the horse outside, and it's going to go, let's see here, 6 goes into 58, 48, we have a remainder of 2. You add another place value here, 6 goes into 23 times, and I'm just going to stop there. This could go on for a while, but it's not important how many decimal places I go out. I just need enough to compare it to these other numbers. And this one only has 2 decimal places, so I'm going to stop right there. So negative 2 and 5/6 is the same as negative 2 and 83 hundredths. Right, 83 hundredths. I should write that a little bigger. Negative 2 and 83 hundredths. Right, so I just really needed to get out to 2 decimal places so I can compare it to number 4 over here. All right, and let's do the same thing with 3/7. 3/7 is what we call a decimal hater. I can't turn 3, I can't turn that denominator 7 into any decimal place value, like tenths or hundredths. So I'm going to have to break out the old cowgirl and horse method here. And that's going to be, let's see, 7 goes into 34 times, with 2 left over, and that's going to be 0.42. And again, I'm going to stop there, because I just need enough to compare it to the other numbers. So this one is 1.42. Let me zoom in here. 1.42, and that's positive. I didn't give myself enough room to work there. So now that I've used the cowgirl and horse strategy to turn those hard fractions into decimals, I can lay these guys out on a number line and figure out who's the biggest. 0, clearly right there. Let's do the positive numbers first. And it's important to kind of write these, I want to write them in their original form. So let's figure out which one of these numbers is closest to 0. I've got 1.42, 1.8, or 125. So it looks like 125, that's number 1. And I'm going to cross that out. And then there's a 142, 1 and 42 hundredths. I'm going to cross that out. And then we have 1 and 8 tenths. Now, I made a mistake here. I should make sure that I write these in their original form. So that 142, that was number 6, right? That was this number right here. So I'm going to write this as 1 and 3/7. And number 2, right here, 1 and 8 tenths, that was 9/5. So I'm going to erase this and write it as 9/5. Okay. So there are all of our positive numbers. We just have these 3 negative numbers left. So remember, the ones that are closest to 0 are going to be greater. So here we have number 7, is in original form, was -2 and 5 tenths. And then 4 and 5. 4 is going to be closer to 0. Remember, 4 was originally written as -2 and 2/3. So -2 and 2/3. And 5 was originally written as -2 and 5/6. So that's the order they go in from least to greatest. Remember, the secret was change them all to decimals, and then they're easy to put in order. Remember to write your answer, though, in their original fraction form. 1, 2, 3, 4, 5. You know, I think I 1, 2, 3, 4, 5. 2 and 5/6. There was a -2. Okay, yes, I was just checking to make sure they were all in the original form. Negative or positive 1.25 is right there. All right. This one is something that a lot of us missed on our interim assessment. So let's just take a quick look. I'm going to call this 0, and we want to know between 3 and 7, what's halfway between the numbers 3 and 7. So there's 1, 2, 3. I should say -7. 1, 2, 3, 4, 5, 6. -7 is right there. So how far away are they? Well, let's see. There's 3 steps there, and there are 7 steps there. That makes a total of 10 whole steps, right? And so if we want to know what's halfway between those 10 steps, we would say, well, let's divide it by 2. That would be 5 steps. So where is 5 steps? Well, you could do it a number of ways. You could say 3 minus 5, and that would come out to be -2, right? Or you could do negative 7, right? Because we did subtraction. We started here at 3, and we subtracted 5. Or we could start here at 7, and we want to go towards the middle. We would have to add 5, right? So -7 plus 5 is going to turn out to be also -2. So it turns out that -2 is right in the middle, right? So find out how many steps there are. If you're asked to find out what's the midpoint, you divide it exactly in half. And then you can, move to the left halfway, or you can move to the right halfway, and you'll get to the correct spot. Okay. Which temperature is further away from -5? Let's pick a number and call it 0. -5 would be 1, 2, 3, 4, 5. That's negative 5. And I didn't leave myself enough room here. I don't think there's enough room on this number line to go by ones, but think about negative 20. How many steps would that be away, right? From negative 5 to negative 20 would clearly be 15 steps. It's negative 15 steps, but we're talking about the distance, right? So you can think of it as maybe the absolute value, right? The absolute value from negative 5 to negative 20 is 15, right? It's the absolute value. It's 15 steps. And let's put 13 over here somewhere. That's positive 13. And I'm pretty sure I know who's going to win this, but let's just double check. From negative 5 to 0, that would be 5 steps, right? So absolute value 5. And from 0 to 13 would be 13 steps. So that's a total of 5 and 13 is 18 steps this way. So clearly negative 20 is closer. Okay, speaking of absolute value, right, number of steps from 0 to negative 48 is 48. 17 minus 36, I would still write that as 17 plus negative 36. And the difference there, clearly the negative number is going to win. The difference between those two numbers is 9. So what they're saying is, if this is negative 9, what's the absolute value of that? Well, it is 9. Because they're asking you, what is the absolute value of this expression, 17 minus 36? Excuse me. So absolute value. This would be, see, I'm going to change this to an addition problem, negative 29 plus the opposite of 119 is negative 119. The negative team got 29 points, and they also have 119 points. We would just add those together. The negative team got a total of 148 points. The positive team didn't score at all. Here, a subtraction, again, I'm going to rewrite it. That's 134 plus the opposite of 259. Right? We get rid of subtraction. And we see here, again, the negative team is going to win because it has the higher absolute value, the greater number of points. And let's find out what? See, 259 minus 134 comes out to be 125. So that's negative 125. Remember, there's no absolute value signs here, so we're just going to stick with our answer here. The order of operations. 5 to the third power is 125 plus negative 25. That looks easy. I might be tempted to just call that 100, except then I would be doing my addition. Excuse me, I would be doing addition before division. And don't let that trick you, right? A lot of people are going to see this and their mind is going to yell out 100. But remember, there's more to the problem here. We have to divide by 5. So don't get tricked into falling out of the order of operations. I'm going to put parentheses around here. Okay, negative 25 divided by 5. Well, if I took negative 25 and broke it into 5 equal groups, each group would be negative 5. Oops, where'd my 5 go? Negative 5. So now I have 125 plus negative 5 would be 120. Done.